Okay, okay. Uh, I'll start now in a sec. Okay, guys. Make sure. Yeah. Just water. Uh, just wait a few minutes. Let me add. Okay. We start now. Just my upper board is not opening. Uh, الحمد لله على السلامة. الله يسلمك حبيبي. Uh, let me end the task here. Okay. Let's start now. I'm going. How do I? Let me pin a message in the chat. Uh, I am solving 3 extra past papers, not only the 5 in the material. In this message. Okay, so why am I doing this? It's because in the old physics material, there were 8. What? There's an echo? Is there an echo? In the old physics material, there was 8 past papers. Uh, Now he removed 3. Just to stay on the safe side, guys, we're gonna solve 8, including the ones that were removed from the material. So this document I have includes all 8 past papers, and we're gonna solve them all. Okay. Uh, can you say I love Fadi? Okay, I love Fadi. Why is someone typing in Spanish, يا أخي? let's get this guy banned. Let's get this guy banned. Is there actually an echo? Is there an echo? I can't. There's no echo, guys. I tested. I don't think there's an echo. Okay, we're gonna start with this. This is October, November 2021. Let me just copy this. Okay, into here. Okay. No. Okay, so this is question 8. What did I eat for dinner? I didn't eat dinner yet. Okay. Figure 8.1 shows a conducting object A initially uncharged. It's held, so this is a neutral object A. It's held on an insulating stand, and they got a positively charged rod B close to object A. They're saying draw the distribution of charges on object A. Obviously, since it's a positive object coming close, obviously what is the positive object going to attract? It's gonna attract negative charges, right? So we're gonna draw negative charges that are close to the positive side. Okay, and what's gonna happen if all the negative charges are over here? We're gonna put all the positive charges over here. What's important here is to know that you must have equal number of positive and negative charges. Okay, they must be equal. It's a mark for that. Okay, so not yeah, here, question 8. There has to be, of course, more negative on the left, and then more positive on the right, like we have here. There's more negative on the left and then the positive on the right. So there's a mark for that. And the other mark is given that you have to have the same number of positive and negative. You can't put 5 and then 4 or 4 and then 5. It has to be 4, 4, 5, 5, whatever. Okay? So for part A, this is how it is. My mic is on. Yeah, okay. Part II, a wire is connected from object A to Earth. State and explain any movement of charge. Statement, explanation. What's going to happen is that the object will be negatively charged. How is the object going to be negatively charged when we earth it? When we earth something, we connect and we let the charges leak outside, right? So what's going to happen when we let the charges leak outside is all these positive charges will go. Then you're going to ask me, Walid, why don't the negative charges leave? It's because the negative charges won't leave because they're attracted to they're trapped here, attracted to the positive side. So what's going to happen is that the object will gain negative charges from the Earth. Right? Let's see the marking scheme. What did they say in the marking scheme? In the marking scheme, they said, you'd say negative charge. It will be negatively charged. Okay. Let's change our answer a bit. Electrons flow to balance positive charge on object. Okay, yeah, let's balance this. So the way they're saying it is, what's gonna happen is that the object will gain negative charges. Why would it gain negative charges? Because electrons, or you could say instead of electrons, negative charges will flow to balance the excess positive charge. Okay. I think I have to put a slow-mo for the chat, wallah. Yeah. How do I make a slow-mo for the chat? I think there's some settings here.
Am I drunk? No way.
Eunice tipped $1.06. Don't use all the money. Get yourself a good meal.
20 seconds. Okay. So over here, let me just explain what happened here, what I did here. Won't it come one of the 5 past papers? Yes, it will come one of the past papers. Okay. What happened here? So obviously, when you earth it, the object will gain negative charges, right? Why will it gain negative charges and not positive charges? Let's see. When you earth it, this is the earthing symbol, okay? When you earth it, electrons will leave, okay? The electrons will leave. Always, the electrons will leave, okay? And when the electrons will leave, what's going to happen is it's going to become positively charged. And to balance that out, what the Earth does is it actually sends back electrons to balance the excess positive charge, okay? What do you mean by balance excess? I just explained it, okay? What happens is when you earth it, okay? When you earth, whenever you earth anything, it always leaks electrons. It always leaks electrons. Always. That's how it works. Because it can never leak protons. You guys know protons don't move. It always leaks electrons. When it leaks electrons, the object will become positively charged. And the Earth, it can't it can't leave the object positively charged. So what it does is it actually sends back electrons to balance the excess positive charge to make it negative. Okay? Memorize this, guys. Please memorize it. Okay? So causes to flow back up. Okay? Hello, Walid. Walid guides with wisdom, bright, easing fears, and studies flight. His smile warms hearts, beast fast, maybe love as lessons last, learning sweet. Okay, thank you, Krista. Walid, we can say with the explanation that the electrons will flow from Earth to balance the positively charged object A. Yes, Jad, you're reading out the marking scheme. You can use that, okay? But I am doing this one here. No, okay. What did you say? Mm, when? Oh, wait. I think I have it muted. Oh, I didn't see it. Me like a thick gal, freaky like me tia. Ugh. But ban this guy, guys. Ban this guy. Walid, why are you doing 3 extra past papers? I'm doing 3 extra because it was originally 8, not 5. Don't the negative charges go up? Yes, they do. They do. What happens at the end is that the negative charges go up. The negative charges will go out, which causes it to be positive, which causes the negative charges to have to go back up to balance that positive. Okay, part A, we're done. Let's go part B. There is a current in a wire of 0.65 milliampere for 2.2 minutes. Calculate the charge. Guys, this is very easy. Q equals IT. Uh,
Am I
you
drunk?
want to find the
No
charge.
way.
We have the current
Grimace
is in
Shaker
0.65
Skibbity Super
milliampere.
Chatted
Can we solve if it's in
2.72
0.65 milliampere? No.
Skibbity
We
Grimace
have to change
Shaking Ohio
0.65
talk to you a
milliampere
gooning.
to actual ampere. How do we do that? It's equal to 0.65 times 10 to the power of negative 3 ampere, right? And in the time, it has to be 2.2 minutes. It has to be in seconds, right? So we have to do times 60. So 2.2 times 60 seconds, right? So it's going to be Q is equal to the charge 0.65 times 10 to the minus 3 times 2.2 times 60. And what do we get? Let's open up our calculator. 0.65 times 10 to the power of minus 3 times 2.2 times 60. You're going to get 0.0858. And you must put the unit of charge, which is Coulomb, right? Let's check the marking scheme. Yeah, 0. They want us to round. Two significant figures. Let me see how much significant figures. Okay, yes, that's my mistake. You have two significant figures, two significant figures. Yes, so you should round this, guys, to 0.086. No. Okay, is it capital C or small c? Should be capital.
Am I drunk? No way.
Sendigo super
Capital
chatted
C.
$20.42. Premium
Okay,
dinner
let me see
J's for you.
the chat.
Dollar bills face, dollar bills face, dollar bills face,
If it was
dollar
a
bills
negative rod, would
face.
it be the opposite answer? If it yes, it would be the opposite answer. Good job. Skibbity Grimace Shaken Ohio talk to a going. Thank you for the 10 dirhams. Krista, have you ever thought about pursuing poetry? Well, if I get 100, I'll let you. Okay. Well, for part B, do we need to write the original formula? Like I could, oh no, you can write any form of the formula. Is this recorded? Yes, it is. Sandigo, okay. Premium dinner just for you. Thank you so much. I'm gonna buy dinner with that, guys. I'm actually homeless and I needed that donation to have my dinner. Okay. Thank you, but thank you so much, Sandigo, for the donation. Well, I really appreciate it. I'll invite you to dinner next time. If I get 100, okay, bro, guys, just ban this nigga. Okay, is there any questions here? I think it's pretty self-explanatory so far. No questions. I'm looking at the chat. Nothing. Okay. I think خلاص we're good. Let's see. Question 5. Okay, this one. I like this question a lot. Question 5. Figure. This came in a past written part, by the way. Okay, this came before in a written part. Figure 5.1 shows two metal plates, A and B, with a radiant heater placed in between them. Okay? Metal A is shiny, metal B is dull black. A piece of cork is attached to each plate using wax. The wax is solid at room temperature and has a melting point of 37 degrees Celsius. State and explain. What happens to the pieces of cork after the heater is switched on? Okay. What's going to happen? Remember, in this experiment, we have a shiny plate and a dull black plate. Remember that dull black surfaces, darker surfaces, absorb more radiation, absorb more energy, right? They absorb more heat. So that means the wax here is going to melt before the wax of A. So that means the cork on plate B is going to fall first. So state and explain what happens to the state and then explain. What happens first? The cork, or no, let's say the wax on plate B will fall faster than the wax on plate A. We stated, right? We stated. Let's explain. Why does this happen? Darker surfaces absorb more radiant, or let's just say radiation, or slash heat energy, and also release more radiation slash heat energy. And then we're going to talk about the shiny surface, right? Shinier surfaces reflect radiation more than dark surfaces and are poor absorbers of radiation. Thus, cork of plate B falls first. Okay. Walid, can you link the 3 extra past papers and their questions? In blue text is the code of the past paper. Okay, in blue text is the code of the past paper. Walid, can you? Okay. It's my birthday today at Watfa. Happy birthday, Abdurrahman. Guys, please tell him happy birthday in the chat. Wallah haram. Okay. Let me continue now. Mr. Walid, I sent you a written from last year. Can you solve it, please? Okay, sure, but after the past papers. Walid, can you tell me 3 past papers because I don't want to wait. I don't know them. I don't know them. I have a list of past papers. It's a file. Okay. Let me see. Let's open the marking scheme for this and explain. Let's see. So it's 4 marks. There is a mark for each. We have to state that the cork on black plate falls off before A. We got that. We said that. So we got 1 mark. You have to say that black surfaces are better absorber than shiny surfaces. We said that. That's 1 mark. And you're also supposed to say that shiny surfaces are better reflectors than black surfaces of radiation, right? Yeah, so reflect radiation, right? So that's 3 marks. And then you have to say the wax on plate B melts before A, right? The wax. Oh, okay. I shouldn't have said the wax will fall faster. I should said the wax obviously. Sorry, my mistake. Why did I say falls? I should say the wax melts, the cork falls. Will melt. Sorry, I didn't mean to say fall. Will melt faster than the wax on plate A. Okay. La 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 la. Okay. Okay. Part B. Give the name of the method of transfer of thermal energy in solid metals. In solid metals, what's the way we transfer thermal energy? Conduction, right? Guys, I'm going to go a bit quicker now because these questions are very easy. Let me see part B. Obviously, conduction. The one in metals is conduction. Okay. Any questions? Let's see. If you said there was 8 originally, what were the 3 that was removed? I don't know them, man. I'm مش حافظهم. I don't have them memory. Secrets the top 8. Okay. If you can make her laugh and giggle, you can make that. Thank you, everyone. Okay. So I stopped. Okay, guys, let's keep the chat relevant here, please. Okay. Question 9. Describe what is meant by the term electric field. I'm not going to give you my own answer because the answer in the Sabbath book is different than the Cambridge answer. Okay, so we're going to show you the one in the Sabbath, in the Cambridge answer. It's the region that an electric charge experiences force. Remember that the electric field is equal to force divided by the charge, right? So in other words, electric field is the region where a charge experiences an electric
Am I drunk? No way.
force. Sendiga super chatted $10.07. What for buy him a cake?
Okay.
Happy birthday Abdelrahman.
Figure 9.1 part B shows 2 parallel conducting plates connected to a battery. On the figure, draw 5 lines to show the electric field between the 2 plates. Okay, let's see. First, we need to know which plate is positive, which one is negative. Over here, this is the positive side of the battery because it's the longer one, and this is the negative side because it's the shorter one. Okay, remember when we have a positive and negative plate that are equally spaced and equal in length, okay, we can simply draw it like this. Okay, 1, 2, make sure it's long, huh? 3, 4, 5. And then you can put a nice E over here. Okay? 5. Let's see the marking scheme for the drawing. Okay? All criteria must be met for the how many marks is it? It's 2 marks. So for the 2 marks, all criteria must be met. 5 lines with both ends within 2 millimeter of plates by eye. Is it 2 millimeter of plates by eye? Yani basically, what they're trying to say is you can't just have an arrow like this. It's far away from the plate. You're not allowed to do this. Okay? It has to be within 2 millimeters. So try and don't make them touch, but leave a tiny space. Okay? That's the first criteria. Middle 3 lines straight and within 10 degrees of horizontal by eye. So the middle 3 have to be straight. Okay? Then they said the top bottom lines can be straight, but some people draw it with curves. Okay? But I prefer to keep it straight. Okay, keep it straight. The spacing between lines has to be in between 7 and 23 millimeters. Okay, I think this is just don't make them too far. Like try and keep them close. You know what? Let me give you a better drawing than this. Let's give it like this. Okay, heck, 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 heck. Okay, these. Let's see here. Walid is uncommoding today. No, he's not. Walid, buy him a cake. Thank you so much, Sandigo, for the donation again. I appreciate you, Wallah. Everyone has ads customized to the relevant feeds. Yeah, that's true, by the way. Walid needs his what? His booze? Awad al-Aidi. Okay. Thank you, Sandigo. Okay. Why 5 lines? They said 5, Habibi. Can we ban Shleezy, please? Anyone who swears in this chat will get a 24-hour ban, please. When fully charged, a 1.2 volt rechargeable battery can deliver a current of 210 milliampere for 10 hours. Calculate the charge that can be delivered. Again, we have the current I and we have the time in T, right? We want the charge Q, okay? Q is equal to IT, right? But the current has to be in ampere and the time has to be in seconds. We're going to write 210 milliampere. How do we make it into ampere? It's equal to 210 times 10 to the power of negative 3 ampere. Then the time, 10 hours is equal to 10 times 3,600 seconds. And my life crashed. Hold up. Crashed on. Let's see. What was a player in school? Okay. طيب ماشي. To find Q, we're going to multiply 210 times 10 to the power of negative 3 times 10 times 3,600, right? And let's see, what do we get? 210 times 10 to the power of negative 3 times 10 times 3,600. You're going to get 7,560 coulomb, right? So 7,560 coulomb. Okay, 7,560 coulomb. But I think they wanted to 2 significant figures. Let me see the marking scheme. Oh, no, they just wanted. Okay. 7. Yeah, see, they wanted to 2 significant figures. They rounded it to this. Okay. Yeah. They wanted to 2 significant figures. Okay, 2 significant figures. Because the least amount of to 2 significant figures is gonna be to 2 significant figures 7.6 times 10 to the power of 3 coulomb. Okay, so 7.6 times 10 to the power of 3 coulomb. Some people may ask me, Why is it 7,600 and not 7.6 times 10 to the power of 3? Very good point. In Cambridge, for IGCSEs,
am
for
I
anybody
drunk?
doing
No
IGCSEs,
way.
okay,
Sendigo super chatted $4.90.
it's important to know
Thank
that they
you
do
for being
significant
family
figures differently.
friendly. What a
Okay,
fee. Green
for
heart.
example, for them, 7,560 is 3 significant figures. They don't count the 0 at the end. That's why here in 7,600, for them in Cambridge, it's 2 significant figures. It's not 4. They don't count the zeros at the end. Okay, I don't know why. So you in Sabis, if you put 7.6 times 10 to the power of 3 coulomb, you're gonna get it correct, no problem. Okay, no problem. 7.6 times 10 to the power of 3 coulomb. And if you get it wrong, I will argue as well for you to get it correct because it's the same thing. Okay, we weren't taught this way in Sabis. Calculate the energy stored in the battery when fully charged. Okay, we have volts, we have the current, we have the time. You guys should know energy is equal to power times time. And we know that P is equal to the current times the voltage, right? Okay, let's find the power first. Okay, P is equal to the current 200, it has to be in amperes, and we know that it's 210 times 10 to the power of negative 3 ampere, right? 210 times 10 to the minus 3. Okay, that's the current times the voltage, 1.2. So it's equal to, oh, let's just keep it like this. Let's keep the power like this. Okay, and then we know what, we can just substitute now the power as 210 times 10 to the power of negative 3 times 1.2 times the time, which is 10 hours. In seconds, it's 10 times 3,600, right? So we're going to round this. Let's solve it. 210 times 10 to the power of negative 3 times 1.2 times 10 times 3,600. You're going to get 9,072 joules. But they wanted to 2 significant figures. So to 2SF, it's going to be 9.1 times 10 to the power of 3 joules. Okay, 9.1 times 10 to the power of 3 joules. Please don't forget the unit. Please don't forget the unit. Please don't forget the unit. State the type of energy stored when the battery is charged. Obviously, guys, you know that the battery stores energy in the form of chemical potential, or is it just chemical energy? I think it's potential, chemical potential energy. Let me make sure of this. Yeah, chemical potential. Oh, you can put any chemical or chemical potential energy. Okay, and here they put 9,100. Yeah, 9.1 times 10 to the power of 3. Okay, let's see. Okay, what was a player in school? Okay, Cece Karim, don't ruin his relationship. Show his reputation like that. He's a player in school. Sure, he's a player in picking his boogers. He does techniques. Oh, okay. Mod stickle his feet. Okay. He scored a pen in pep rally. He's crazy. Uh, okay. Thank you for being family friendly, Watufi. Thank you so much again for the donation. Bro, like, okay, thank you so much, Wallah Sandigo, for the donations. خلاص, stop random chatting. Bro, Sandigo, leave some from your. Can we say W equals PT or does it have to be E? I'm pretty sure you can put W equals PT as well. But listen, you should be able to say W equals PT. But since you're saying energy, just use E. Why do you want to use W? Okay. I'll wait 30 more seconds and I'll move on. This text is wrong, by the way. Oh. Okay. Let's go next. Question 8. For the Q equals N times E, what is N is number of electrons. Figure 8.1 shows a negatively charged conducting sphere. On figure 8.1, draw the electric field pattern around the sphere. Okay. Electric field. What about the electric field? We know that electric field goes always from positive to negative. Do we see any positive particles here? No, we don't. What are we going to do? We're just going to draw to each negative particle. Right? Since there's no positive, we're just going to connect any random line to the negatives. Okay? Try and make them equally as long Oh, by the way, guys, for the drawings, make sure you get a pencil with you. Let's see here. What do they say? In it's radial lines coming to sphere, and the arrows should be pointing towards the sphere. So if you draw it like this, that's two nice, easy marks. The current in an electrical device is 0.21 ampere. Calculate the charge that flows during a 75-second period of time. Charge is equal to Q equals I T. Right? The current, it's already all given in the units we want, so very easy. Current is 0.21. The time is 75, and you get 0.21 times 75. It's 15.75 Coulomb, but they want it to two significant figures. It's going to be 16 Coulomb. Okay, don't forget the unit. Don't forget the unit. Okay, 16 Coulomb. 16. Okay, let's see. Any questions? Which past paper do you think will come? Honestly, from what I'm seeing, I think he'll get two past papers, not one. Because these questions are very short. Well, they can be done in like what, 1 minute. Would they ask us to draw a circuit in written, or you doubt? Honestly, if there's no, I still haven't solved all the past papers. If there's a question that might say to draw a circuit in one of these past papers, then yes, 100%. Okay. Figure 8.1 shows a positively charged cube of insulating material. Okay. The cube is fixed to a piece of wood that is floating on water. A negatively charged rod is held above the piece of wood and brought close to the cube as shown. State and explain any movement of the piece of wood. There shouldn't be any movement of the piece of wood. Fixed to a piece. Oh, it should move towards the negative, right? Let me see. It's question 8. Should move towards the negative. Yeah. Okay, yeah, obviously. So, what's happening here is there's a positively charged cube which is fixed to a piece of wood. So it's attached to this wood, right? And then they got a negatively charged rod and they got it close. What's going to happen? Obviously, the cube is going to move towards the negatively charged rod. But since the cube is attached to this wood, the wood will also move along with the cube. Okay, so what's going to happen? The wood will move towards the negative rod since it's attached to the positive cube that is attracted to the negative rod because opposite charges attract. Okay. This is nice, 2 easy marks. The wood will move towards the negative rod since attached to the positive cube that is attracted to the negative rod because opposite charges attract. Okay. Figure 8. Okay, any questions? Wait 30 seconds. What's my delay now? خلاص, I don't think there's any questions. Okay, double I. Figure 8.2 shows two cubes of insulating material. One is positive and the other is negative. Okay. Okay. The cubes are fixed to a piece of wood that is floating on water. Charged rods are held above the piece of wood and brought close to the cube, as shown. State and explain any
Am I
movement
drunk?
of
No,
the
wait.
piece of wood.
Sendiga super
Should be
chatted
no movement, right?
$10.07. Please don't forget the appetizers for your dinner.
This is a nice question. This is a very nice question. Okay. Okay. Let me explain what's happening here. Here in figure 8.2, it shows two cubes of insulating material, right? The positive one and negative. One is positive and the other is negative. The cubes are fixed to a piece of wood that is floating on water. right? They're both of these cubes are attached to this piece of wood, the circular piece of wood. Then they got charged rods that are held and brought close to the cubes as shown. Okay, so they got the charge, a positive rod close to the negative one, and the negative rod close to the positive one. State and explain any movement of the piece of wood. What's gonna happen here? مش صح here, there's gonna be a force that's attracting here, right? And also here, there's gonna be a force of attraction, right? So don't you have two forces in opposite directions but same magnitude? And doesn't that cause a moment? That causes a moment, صح? That causes a moment. Because this force will go like this, this force will go like this, and what's this gonna cause? It's gonna cause the spinning of the circle. So honestly, I think he might get this one, صراحة. So state and explain any movement of the piece of wood. What's gonna happen? It will cause the spinning of the wood, since two forces cause a moment. I think that's it. What do they want us to write anything? It spins. Two forces cause a moment. Right. That's it. Nothing else. You don't have to say anything else. Can you repeat? Okay, yes, I can repeat. From grade 10. From grade 10. Okay. When you have a wheel. Okay. When you have a wheel. Remember, this is from grade 10. Physics, grade 10. When you have a wheel and you put a force like this, and then you put a force like this, it causes this wheel to turn, right? It causes this wheel to turn. So why does it cause this wheel to turn? Because it causes it to move like this, and this one causes it to move like this, right? It's a turning effect. This is, remember when we had moments? Remember that the moment from last year, moment is equal to F, the force, times the d perpendicular. Remember when you used to have a center here and used to have a force that goes like this, and it was like 2 meters away, and this was 4 newtons, and they'd ask you to calculate the moment, the turning effect of this force on this torque here. That was 8 Newton meter. Remember all this moment? Okay, but how are they opposite motions? How are they? Don't forget about the opposite. We don't care. I don't care if it's opposite. Okay? All I care is that since I have two forces, it's gonna cause a moment. Okay? They're both, even if they're both acting in the same direction, I don't care. I don't care about the direction. All I care is that it's gonna cause a moment. Please don't forget the appetizers for your dinner. Thank you again, Sendigo. Thank you. I really appreciate it. I'm gonna have a nice lunch and dinner this weekend, and I'm gonna post it on my Instagram, and I'm gonna tag you. I think this is understood by everyone, because I explained it 3 times now. In terms of a simple electron model, describe the differences between conductors and insulators. Okay, this is very easy. They're saying in terms of a simple electron model. All you have to say, I think, is this one required? Okay, yeah, good point. Is this one required? Let me see. October, November 18. Question 8. 4-2. Is this 4-2? Yes, this one is required. Okay, this one is required. Let me see. The one above, was it required? I think he removed this one. October, November 1943. Yeah, this one here was removed. The easy one. I told you, I don't think he'll bring it. This one, 4-2, October, November 19. This one isn't removed. This one's still here. This one over here, 4-3, October, November 20. This one was removed. This one was removed. This one, 4-2, October, November 21. This one is still here. This one is so. This one is removed, and this one is removed, but this one is included. Are these okay? Wait, even if it's both in the same direction, it will turn anyway. Exactly. No, it won't spin, but it will cause a moment. Okay. If they're if they're in opposite directions, they won't spin, but will cause a moment. I think, guys, that doesn't matter. There's no need to for this. For this one, I think I just want to see. Yeah, okay. This one's very easy. In terms of simple electron model, describe the difference between a conductor and insulator. Guys, in terms of electrons, you have to talk about electrons. In conductors, what do we know about electrons in conductors? In conductors, they have free electrons that can move. In insulators, the free electrons are absent and its electrons can't move. On figure 8.3, draw the electric field pattern around a single positive charge. Okay, let me take this up. Okay. Here we want the electric field. Right? Remember, electric field is always from positive to negative. In this case, we have our positive, but do we know where the negative is? We don't know where this negative is, right? We don't know where the negative is. So what are we going to do? We're just going to draw lines moving away from the positive. Okay? That's it. Let's see. The at least 4. Yeah, it has to be at least 4. Evenly spaced straight lines with correct arrows outwards. They have to be evenly spaced and they have to be same length, guys. Don't draw it like how I did. Let's draw it a bit better. Please get a ruler with you. 1, 2,
Am I drunk?
3.
No way.
Sendiga super chatted $1.98.
Okay. Willis, can you please
Don't
upload
forget
this
the
file on your
drink.
drive now?
Winking face.
Okay. But remember, this is not only 5. This is 3 extra ones. By the way, does written come copy paste to the past paper? It should be, yeah. There was a negative charge given with the outer arrows be curved. If there was a negative, yes, they would. If there was, it would. Let me close my screen because I want to upload the paper to the. Please, by the way, this credits to Aisha in Shwaifat, Dubai. She's the one who sent me this file. So all credit goes to her, guys. Sendigo, 7 dirhams 29. Don't forget the drink. Isma, you're spoiling me, wallah. Thank you so much. Okay. Sendigo, by the way, where are you from? Where are you from? I uploaded, by the way, guys, the one here. Okay. لا ده منظم. Okay. Describe what is meant by an electric field. Again, for those, by the way, who are doing IGCSEs, who maybe have not done them last year, the Cambridge board likes to repeat their questions. So they always bring similar questions. You get what I mean? So like you might see this in one paper and they might bring it again in another paper. Okay. I'm local. Okay. Okay. Basic, I was asking. Describe what is meant by an electric field. We had it before. It's the region of charge that is affected by an electric force. Let's check if this is the correct answer. It probably should. We did this before. Is the region that experiences a force. Okay. Let's say electric charge. Let's say electric charge, right? Electric. Okay. What is meant by the direction of electric field? It's the flow of, I think it's from positive to negative, so it's the direction of, it's the direction of force on a positive charge. Okay. Yeah. So the direction of an electric field, you know how the direction of electric field is always positive to negative? So I think that's what they mean, is the direction of force on the positive charge. So it's the direction of force on the positive charge. Very easy, 2 marks. Figure 8.1 shows a polystyrene. Let me take this off. Okay. Figure 8.1. I'll just delete this. Shows a polystyrene ball covered with an aluminum paint. Okay. The polystyrene ball is suspended between two charged metals by an insulated thread. The ball oscillates between the two charged plates. Explain why the ball oscillates. Oscillates means goes left and then right, and then left and then right. Okay. I think I have a reason why. So I'm gonna look at the mark scheme first. Okay, yeah, it's exactly. This was, by the way, in the book. Okay, why does the ball oscillate? The first thing is, what's it say? Yeah. The first thing is the ball. It's aluminium, so it will be attracted to the positive, right? Our sheet's neutral, so it's gonna be attracted to the positive. Ball is attracted to the positive plate. Then, when it gets attracted to the positive plate, what's gonna happen? It's gonna hit it, right? When it hits it, what happens to the charge of the ball? It becomes positive. And when it's positive and it's beside the positive plate, what happens? It's gonna repel it. Repel it all the way where? To the negative charge. And when it hits the negative charge, it's gonna hit, same thing gonna happen. It's gonna hit it, become negative, then be repelled by negative, then go back. Ball's attracted to the positive plate, then hits the, I'm gonna write it like this, positive plate to become positively charged. Then it is
Am I
repelled
drunk? No way.
M7MD super
By
chatted $1.98.
the positive
If
plate
you meow, I'll send more.
where it hits the negative plate to become negatively charged, and then when it's negatively charged, it becomes repelled now by the negative plate. Okay, let's check. Is this 4 marks? The ball moves towards the positive plate. We got the first mark. It touches the positive plate. Yeah, it hits the positive plate. We got that. Okay. We didn't say it's made of conducting material to become positively charged. We didn't say that, but we just said it becomes positively charged. I think you should get the mark. Then we said it's repelled from the positive plate. Yes, we got that. Touches negative plate and loses charge. Okay. Let me explain this again. So it loses the charge. Okay. Close. Let's explain this again. I'm gonna change my answer just a bit. Okay, let's change the answer a bit. Plate become okay. You know, I'll erase all of this. Here, okay. Before I explain again, I think I saw a few questions here. Bro, what did you write at the region of charge? I don't understand your question, Shobaki. By the way, do we have to write the definitions copy paste or can I use different words? Obviously, I'd prefer you to write them copy paste. Send a code, please send more money. Okay. Why is it attracted to positive? Hala, I'll repeat again. If you meow, I'll send more. Thank you for the donation, but I'm not meowing, Habibi. I'm not going that low for money. Does the order matter? Can I say first is attracted to negative, then repels to go to positive? Explain again, please. No, you cannot say it goes to negative first. It's always attracted to the positive one first. Neutral plates are attracted to positive plates before negative, okay? I think. And if you could, then in the marking scheme, they would say, or the other way around, okay? You're not allowed. So what happens? This ball here is neutral. Neutral plates, all of you should know that positive charges attract neutral. Negative charges also attract neutral. But the attraction force between a positive plate and a neutral plate is larger than the attraction force between a negative and a neutral. So that's why. What's going to happen is the ball, it's attracted to the positive plate. When it's attracted to positive plate, it's going to hit it. It's eventually going to hit it, right? It's going to hit it. It's going to hit this positive plate. Since the ball, it's aluminum, right? It's a conductor. Since the ball is conductor, it will gain a positive charge when it hits the positive plate. So now the ball is positive and it's beside the positive plate. What's going to happen? It's now going to be repelled by that positive plate. The positive plate repels the ball so now it's going to repel it. It's going to go where? Till it hits the negative plate. So now it's going to hit here, the negative plate. Till it hits the negative plate. What happens when the ball hits the negative plate? Does it become negative? No. It was positive. You cannot go from positive to negative. It's going to lose its charge. It's going to become neutral again. Okay? Where it becomes where it loses its charge. Where it loses its charge. After it loses charge, doesn't that mean it's neutral again? Doesn't that mean it's same as stage 1? Doesn't that mean it's gonna get attracted again to the positive side? And this whole cycle repeats again? Yes.
Am I drunk?
So,
no way.
M7MD super chatted $1.98. In my mind, I'm always the best.
To the positive plate. And the cycle repeats again. Okay, let's see questions. Okay. In part AI, what you wrote doesn't make sense. You wrote in the region of charge. What I wrote didn't make sense. What did I write in part AI? What is meant by electric field? It's the electric charge that is subject to an electric force. I don't see what's wrong. I think maybe I would have said the region of electric charge. Okay, the region of electric charge is also correct. But okay, if you're saying that, if you say so, okay, I don't care. Like, wallah. The region in which an electric charge, even it's in the marking scheme. You should say the region of electric charge. It should be the region. The part, which place of the electric charge It's subject to the electric force. That's what the electric field is, Ahmed. You're smarter than this. Why is it neutral? Isn't it plastic meaning negative? Where did we see plastic? Okay. Very good point. See, this is where people get tricked. It's covered with aluminum paint. Aluminium is a conductor. It's covered with a conductor. So now, even if it's made of plastic, but it's covered with aluminum paint, and the aluminum, it's a metal. So now, it's deemed as a conducting sphere. Okay? Let's see. Did they mention in the book that the force between a neutral object with a positive plate is larger than with a negative plate? No. Neutral conductors and neutral insulators are always attracted to positive charges only. No. They are attracted to negative. No. They are attracted to negative. Guys, they are attracted to negative. How do we know it's conducting like the ball? It's because it's aluminum. Neutral attacks. Yes. Guys. Electric charges and charge.
Am I drunk? No way.
M7MD super chatted $1.98.
Loads.
Cristiano 3MK.
Should be on the second page. Somewhere. Ya Allah. Okay, Ahmed. It does attract negative. Who said it doesn't, guys? No way. And I would not say this. Never. I'd never say this, guys. No way. It's in the book, because I remember. I read it in one of the notes videos. I even said it. I said, guys, even this is how it's said in the book. Ya Allah. Ya. Guys, I hate the ebooks. Wallah, I hate it so much. It's so slow. Okay, maybe if it shows here. Yeah, I don't know. It's in the book somewhere. Maybe here. But I'm 100% sure. I don't know why my ebooks it's not working. Physics. Because it's not working, guys. Let's just continue. But I'm 100% sure it's attracted to negative. Okay. Yo, can you please make Mechanics CA tomorrow? I will upload it tomorrow. There's a current of 0.29 amperes. Calculate the time taken for 15 coulombs to flow. Q equals I T. Thus, T will be equal to Q divided by I. Right? The charge Q is 15 over the current 0.29. And you're going to get 15 divided by 0.29. It's going to be... Whoa, okay, 51. We want it to be two significant figures. So it's going to be around 52 seconds, right? Let's round two significant figures. 52 seconds. Please don't forget the unit. 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 Okay, this is... I said it 5 times. What about? Please don't forget the unit. It once came in the CA. It said neutral conductors and neutral insulators are only attracted to positive charges. It even came in the course practice quiz. No. It is attracted. Please stop confusing them. I'm 1000% sure it's attracted to negative charges. Okay? I'm gonna find it for you. I have to find it for you. I'm telling you, I'm not gonna end this stream without finding it for you. I think it's the next page here. Yes. Attraction of neutral bodies by charged objects. Okay. Attraction of a neutral conductor by charged objects. It is observed that when a neutral conducting sphere is brought near a charged rod, the sphere is attracted to the rod. They said charged, right? For instance, consider a plastic rod and an uncharged conducting sphere. Positive charges within the conducting sphere are attracted towards the negatively charged plastic rod, while the negative charge is repelled away. This results in a positive charge near to the rod. La 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 la. Guys, let me explain it for you. If you have a negative rod, negative, 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 and you have an uncharged object, it's going to attract the positive charges. And this will cause an induced attraction force. So it will cause an attraction. So no matter if you're bringing a negative or a positive object closer to a neutral object, it will always have an attraction force. If an insulator is brought near a charged object, it's attracted to it. Although charge cannot move through the body of the insulator, charge can be slightly displaced, but cannot. Okay, this is enough to cause a net attraction. Okay, please, yani, this is the. It's very basic, guys. Okay. Question 10. How many do we have left? Two. I think we have two more papers. Okay. Yes. An uncharged conducting metal plate rests on insulating supports. Figure 10.1 shows the plate and the positively charged insulated plastic sheet placed on top of the metal. Describe any flow of charge that takes place when the plastic sheet is placed onto the metal plate. Let's see what's happening here. So we have an uncharged conducting metal plate. So this is the metal plate. It's neutral. It's resting on insulating supports. Figure 10.1 shows the plate and a positively charged insulating plastic sheet placed on top of the metal plate. So we have a plastic sheet up. Describe any flow of charge that takes place when the plastic sheet is placed onto the metal plate. I don't think there should be any flow of charge because it's insulating. Let's see. Let's check the answer. Electrons in the metal move up. Okay. That's what they mean. Okay, yeah, makes sense. Like I just explained, whenever you bring a positive object near to an uncharged neutral object, the positive objects will attract negative charges up, right? It's going to attract negative charges. So negative charges will flow to the top of the metal plate. On the figure, draw how charges are now arranged within the metal plate. So yeah, akid, if the negative ones are up, then the positive ones will be down. And I think there should be equal number. Let's see the mark scheme. More negative charges in the top and not if contradiction. For example, more positive in top and more negative. Huh? More positive. Okay, yeah. This is how it looks. State and explain if this arrangement of charge helps to keep the plastic sheet in place. It will keep the plastic plate in place because it attracts, right? Yes. Yeah, of course. Yeah. And I'm just checking the marking scheme, guys, in case I don't want to give you a wrong answer. Okay. So state and then explain. 1 mark for each. Does it help to keep the plastic sheet in place? Of course, it will help to keep the plastic sheet in place. Why? Because there's going to be attraction force between this positive and this negative, right? So yes, it will help keep it in place because unlike charges attract. Can you repeat this question? Wow, guys, come on, this is so easy. Describe any flow of charge that takes place when the plastic sheet is placed onto the metal plate. Okay, read the question. Uncharged conducting metal plate. When you say something's uncharged, yani it's neutral. Okay, but we never say neutral, we say uncharged. Okay, imagine this isn't here. So you have a neutral plate and then you have a positive plastic, right? So you have something neutral and you have a positive object near it. What's gonna happen? The positive charges will attract what? It's gonna attract negative charges. That's why in the metal plate, the negative charges will flow up to the top of the metal plate. That's it, guys. It's so easy. And then obviously you just draw it: negative, 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 and then down, positive, 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 positive. Okay. Figure 10.2 shows two uncharged conducting spheres suspended on insulating threads. Okay, so there are two neutral spheres suspended on insulated threads. Okay, the spheres are now both given positive charges. Okay, so they're both given positive charges. They're both now positive. Draw a possible position of each sphere and thread. Obviously, it's gonna look like this. Right? Because when they're both positive, it's gonna repel. Right? Both threads angled away. And then they said explain. Yeah. They said explain like charges repel. Very easy. When do you use E as negative, and when do you use it as positive? I always use it as positive, and then depending on what they want in the answer, I make my answer positive or negative. That's what I do. Can you repeat the last two? Just play back the video. Okay, play back the video. When people ask me, can you repeat? And I don't understand what they mean by repeat, you can just go back in the recording. When you ask me to repeat something, it's because you didn't understand something specific. Ask me what you didn't understand, and I will explain that in detail. That way, you can understand when I repeat again. Because when I repeat again, I'm just repeating the same exact explanation. And if you want the same exact explanation, you can just go back 10 seconds. Oh. Oh, it doesn't mean that. I'll explain it. Okay. Uh, okay, if air is an insulator, how come induction happens? Like, isn't the space between the charged glass rod and the air enough to stop the charge, or is there a specific distance? This, when I say air is an insulator, I mean air is an insulator as in like heat. Okay, not like this. Nadim. Okay, we're gonna ban this guy. Okay. Did you study religion? No, I didn't. Not yet. I'm gonna study now. Okay. Question 9. This is our last one for today. After you're done, okay, go to the physics CA video that I will upload. I think my software crashed. But anyway, go to the last question of the physics CA video for week 7 and watch it, because I think he's gonna get it in the computer part. Okay? Please make sure to watch it. Or if you want, I'll just explain it now. Yeah, I'll explain it now. I'll explain it now. Make sure to pay attention for it, because I think you'll get it computer part. Figure 9.1 shows a conducting ball that oscillates between two charged plates. Okay. The ball repeatedly strikes each plate in turn. Explain in terms of the charge in the ball why the ball moves to the positive plate after striking the negative plate. So here they're saying they forced, like they made the ball strike the negative plate. They're saying, why does it move to the positive plate after it strikes the negative plate? Let's see. When the ball strikes the negative plate, what happens to the charge of the ball? It becomes negative. And what happens when it becomes negative? It becomes repelled from the negative plate. So it repels and moves back to the positive. So that is a very easy explanation. What can I say? After the ball hits the negative plate, it becomes negatively charged when where it is meaning, or thus, I don't know, what do I say? Thus it is repelled from the negative plate. When charged negative glass spheres are brought near uncharged metal spheres. Why don't the electrons from the charged sphere just jump to the uncharged metal sphere? Listen, listen, listen. For electrons to move, the two objects must be touching each other. They must be touching. Electrons cannot jump through air. That's not how it works. They can't jump through air. They need to be in contact with each other. And even in this example you gave me, oh no, never mind. Yeah, electrons cannot jump through air. That's why. Can you open the question I sent, because I don't know if it's in the material or not. Okay. Khairi, I'm gonna ban you because I really, really hate when people send these things on my channel. Please don't send these things, guys. Let me open what's up. Yes, this is included. Okay, this is a very easy question you sent me. It's like any other question I solved in the... It's a resistivity question, guys. Very easy. Very, very easy. It's like the questions I solved in 2 point... I think it was 2.18, because we didn't say the ball loses charge if it hits the positive plate. Okay. Yes, Hamza, I did say that. But that was for the case that when I hit the positive one first and then go to the negative. But here, what did they say? They struck the negative plate first. Okay? What's the question? I'll solve something that looks like it after I solve this. State which particles move through the sensitive ammeter and the direction in which they move. Huh? Sensitive ammeter. If negative, then it goes here. Okay, then should be positive particles. Should be positive, right? Electrons from L to R. What? From L to R. I honestly don't understand this answer. What do they mean by electrons from L to R? What do they mean by this, guys? Okay, I would get why it's electrons, because electrons are the only thing that move. Let's say it hits here. Negative. Okay. Okay. Yeah, guys, why? Yeah, why would it be? Okay, I know left to right, but why is it left to right? أكيد it means left to right. I'm not stupid. But why is it left to right? Why would it be left to right in this case? Let me state which particles. Yes, you need a pencil. And move through the sensitive ammeter and the direction in which they move. What's the direction? From left to right. Left side of the figure to the right side, because they flow from positive to negative. Okay, I get that. I understand that. But here it's going, the ball is hitting the negative plate where it hits negative and releases electrons. But how? From positive, so it goes like this. They mean, okay. I think what they mean is from left to right, it starts left, then it goes right like this. But okay, I think they mean like this. Can someone confirm? The ball takes electrons from the negative plate to the positive plate. Okay, Then the electrons travel down from the positive, from left to right. Current flows from positive to negative. And you're using an ammeter, it can't go negative. I understand that, but is my drawing correct? Can you confirm this, guys? If it's wrong, explain why, please. The positive terminal is on the left and the negative is on the right, so you are correct. Okay. Okay. State which particles move through the sensitive ammeter. Obviously, electrons will move because current is the flow of electrons or charged particles, right? So electrons will move from left to right. So it's positive to negative. Okay. Part C, for each complete oscillation of the ball, moving between the plates, a charge of 8.5 times 10 to the power of negative 10 coulombs is traveled from one plate to the other. The frequency is 4 Hertz. Calculate the current shown on the ammeter. Let me see here. You have frequency. The only equation with frequency is E equals HF. If you have the energy, you have the coulomb. Current equals QIV. I don't know. How would you do this? Is there a formula I'm missing? Q equals IT. Okay, correct use of F equals 4 Hertz. Okay. This won't come. Guys, this one won't come. Listen, 4 Hertz. This won't come. Guys, this will not come. Part C will not come because you're supposed to use that 4 Hertz is the same as T equals 0.25 seconds. Okay, it will not come. Don't forget. Time is equal to 1 over frequency. I know. T is equal to 1 over F. Yeah, guys, I know, but we never took T equals 1 over F. Or did we take it to one? I'm tweaking. Guys, did we take T equals 1 over F? Wait. We never took T equals 1 over F. Yeah, not that I can remember. When did we? Guys, we took time is equal to 1 over frequency. No, we never took T equals 1 over F. I don't remember taking T equals 1 over F. This is different physics. It's not the physics we took. In mechanics, no, we did not take it in mechanics. Frequency, no. In mechanics was something else. That's for a complete revolution. That's something else. Yeah, Habibi, no, they didn't. I have Mr. Ghassan. He didn't teach me T equals 1 over F. لا تتفلسف. It's wrong. We never took T equals 1 over F. Either way, if you do get this, T is equal to 1 over F. So T is equal to 1 over 4, which is 0.25 seconds. So we have the time. We're going to use Q equals IT. Hence, I is equal to Q divided by T. So I is equal to 8.5 times 10 to the negative 10 over 0.25. Ahmad, do you remember taking T equals 1 over F? I honestly don't remember taking it. Never in my life did I take it. Because I know the formula exists. So we're going to get I is equal to 3.4 times 10 to the minus 9 ampere. It's two significant figures, so you can just put 3.4 times 10 to the minus 9 ampere. Please don't forget the unit. Please don't forget the unit. Let's see. Yes. Yeah, I'm telling you they're yapping. I never took this in my life. But it is a formula, by the way. Frequency and time. T is equal to 1 over F. I've seen the formula before. It's frequency. It's equal to lambda T. Some stupid shit like this. But that's for something else. It's not for the physics we've taken. Before I end this live, week 7, physics CA, I'm going to open the last question. We're going to solve it because it's some people will not know this. And just when it comes, so nobody comes and tells me you never did this for me, whatever. Power is transferred from a power supply lamp 23 meters away. So they gave you the length of the lamp via a cylindrical copper wire. So they gave you the length of the wire. The resistivity is 1.72 times 10 to the power of negative 8. So they gave you rho. And the maximum resistance is 0.1. So they gave you R. What do they want? They want the diameter of the copper wire. Here, people will see diameter and they're just going to start panicking. Why will they start panicking? They'll be like, oh, what is diameter? Now, what is the formula we know? We know that R is equal to rho L over A. This here is a cylindrical copper wire. The area, the cross-sectional area of a cylindrical copper wire is the area of a circle, right? The cross-section of a cylinder. You have a cylinder, right? Heck. Cut a slice. What is it going to be? It's going to be a circle. So it's going to be area of a circle. So the area is equal to pi r squared. I know that the diameter of a circle is equal to 2 times r. So if I can find the area, I can find the diameter. So let's find the area. There is the resistance 0.1 is equal to the resistivity 1.72 times 10 to the power of negative 8 times the length, which is 23 over A. And you can just find it easily. You're going to get 0.1 equals 1.72 times 10 to the power of negative 8 times 23 over, we can say x, right, instead of A. Let's solve this on a calculator. We're going to get this. So the area is equal to 3.956 times 10 to the power of negative 6. Can I find the radius now? We know that this area is equal to pi r squared. How do I find the radius? It's going to be equal to radius squared is 3.956 times 10 to the negative 6 divided by pi. صح? Okay, let's divide our answer by pi. Answer divided by pi. You're going to get this. Okay, and with squared, so we're going to square root it. So we found our radius, and we know the diameter is equal to 2 times the radius. So we're going to multiply this by 2. Okay, times 2. We're going to get this. They want the answer. This answer that I got is going to be 2.24 meters. Right? 2.24 times 10 to the power of negative 3 meters. The answer they want is in millimeter. So what do? We multiply by 10 to the power of 3. So it's going to be 2.24 millimeter. Okay? That's it. 2.24 millimeter. Explain Van de Graaff generator real quick, please. And also the V equals E minus R or something. Van de Graaff generator, there's nothing. اسمع حبيبي. You tell me also electroscope. حبيبي شو أنا. It's the end of the live. You can't ask cake. Van de Graaff, I feel bad والله. I'll explain quickly. I won't do electroscope. If we convert. No, don't do this. Shobaki, don't do this. Always solve with the SI unit. Don't convert at the start. It's pointless. I'll quickly explain the Van de Graaff generator for this guy and the electroscope, even though my computer doesn't want to load. Let me see if I can open it from my downloads. Uh, okay. All you need to know for the electroscope is that it utilizes the principle of repulsion. Okay? How it works is that when you get any charge here, the charges of that object, let's say I have a negative charge object, those negative charges are going to flow down here, and it's going to charge the metal plate that's over here, the charge that you gave here, negative. Okay? And if the electroscope is originally negative, that means you're going to have negative, negative, and the gold leaf will repel. But sometimes they might tell you that the electroscope isn't originally negative. They might tell you that the electroscope is originally positive. Now you have negative, positive. So what's going to happen to the gold leaf? It's going to come closer. It's going to attract. Okay? That's electroscope. There's nothing for me to explain here. Then the Van de Graaff generator. All that happens is in the Van de Graaff generator, you have a belt, and here it has friction. Friction causes electrons to be made. Okay? Over here, it rotates. So these electrons will come here. But it's also connected to a wire which earths it. So it's basically going to release all these electrons outside. So now, you got rid of all your negative charges. What's going to be left? Only positive charges. And these positive charges will come up here. Okay? That's it. Nothing to explain. Yes, you need pencil. Is that quiz question coming? I think it will come. Chapter 2, Section 15, Exercise 2.4. That's very specific. Chapter 2, Section 15, Exercise 2.4. Let's see. Exercise 2.4. Okay, determine the potentials at A and B. Where? Ah. Okay. Okay, yeah, okay, guys, come on, what's this stupid question? They're saying, look, if B is the grounded one, that means the VB is 0, and then A will just be 10. Here, they're saying if A is ground, then VA is going to be 0, and VB is 10. This is a very stupid question. I feel so unsure for tomorrow. Wallah, I have no words for. Will I lose marks for using pen? Please don't draw on pen. You won't lose marks. Maybe. Honestly, it depends on the person correcting for you. I don't care. But I don't think you will lose marks. But please draw on pencil. Khalas, guys. We are done. Thank you so much for watching. I appreciate you guys today. Good stream. Solved all the 8 past papers. Thank you so much for watching. It's 0 minus 10. Are you sure? Wait. Before I end, why is it 0 minus 10? Why is it? Why is it 0 minus 10? It should be 0, 10, no? No way, it's minus 10. Huh? Why is it negative? If the potential difference between 2 points A and B is 10, with B being grounded, the potential at VB is 0 and VA is 10. Suppose that A is ground instead. B minus A. To find the potential difference for VAB, you do A minus B, so 0 minus 10, so okay. Okay, so they're saying VAB is equal to 10. So that means VA minus VB is equal to 10. Okay. And they're saying, so when VB is equal to 0, yeah, so 10 minus 0 is 10. In this case, if A is ground instead, that means VA is equal to 0. So let's substitute 0 minus VB is equal to 10. So VB is equal to negative 10. Okay, yes, I get it. Thank you so much. Thank you so much, Sonal. Thank you also so much, Jamil, for pointing this out. That's a very oddly specific question to ask Moon Siddiqui. I don't know why. Last time, for the last physics periodic, someone came in my live and he said, do this question. And the exact question came in the computer part and everybody got it wrong because of something specific. I feel like, I don't know, I feel like the same thing is going to happen now. Okay. Anyway. Thank you for your time. Thank you so much for tuning in today. Thank you guys. Thank you. خلاص. If you have any questions, please put خلاص before I end. Other than that, we're done. I have to study religion. Anything, guys? Okay. Good night. Good night. Thank you. يلا. يلا.